Hello, family. Welcome to another session of Maths Fanatics 24/7. In this video, we're going to be looking at probability, contingency tables, and the fundamental counting principle. Okay, so 11.1 is suitable for grade 11. And 11.2, it's suitable for only grade 12. So if you're in grade 11, you are just going to do 11.1 only. 11.2, it's for matric, it's permutations. But for fun purposes, I advise you to also look at it just to see what you're going to be expecting in the following year. Okay, so without wasting time, let's go straight to the questions. So they say in a survey done at a local traffic department, the following information was obtained. Then this information is represented on a what? On a contingency table, right? Perfect. So I'm going to highlight this number here, right? The number at the bottom right corner né, is the most important number. Né? This is the total sample space. Né? This is the what? This is the sample space. Sample space. So what I'm saying here is any probability that you're going to do, you are going to always say all over 1,600. This number at the corner is the total sample space. Awesome. So now let's calculate this questions here. They say calculate the probability that a person selected at random will be a male. So male is here. And then we go there, the total males is 1.2. So the answer to this question will be 1,200 over 1,600, right? If you press this on a calculator, it simplifies to 3 over 4. Ne? Some people leave it in decimal places or percentages, but I advise you to always leave it in common fraction because my observation of memorandums is mostly it's always in simplified common fraction. Awesome. So now they want us to calculate the probability that a person selected at random failed a test. Let's go to failed. Failed is there. The total fail is 200, right? So the answer to this question will be 200 over the sample space, which is 1,600. This simplifies to 1 over 8. Right. Awesome. And then they say, okay, let me just erase this part here. Let me just erase this part. We now know that it's a sample space. I just need a space there. Awesome. So let's use a different color here. Sharp. So they say, if being a male, so male, and failing a test, right, are independent events. Remember, I said, if you hear the word independent, the formula that comes to my mind is this. So I'm comparing male and what? And failed, right? So this is where they meet, né? Male and fail meet here, right? Fail there, sharp. So probability of male and, remember this means and, né? It's another symbol for and, right? Probability of male and fail is the same as probability of male multiplied by probability of fail. Ne? Because they're saying being male and failing are independent. So remember, independent probability of A and B is the same as probability of A multiplied by probability of B. If they say independent, I always going to be thinking of this formula here, right? Perfect. Now they say show that the value of A is 150. Okay. Remember, P male and fail, it's A over 1,600. Always over this, ne? Always, right? Sharp. So P male who failed, it's the event is A, ne? Over the total, which is 1,600. And then P male we calculated to be 3 over 4 multiplied by probability of failing, which is 1 over 8. They're already calculated there, right? Awesome. And then, so that A remains alone, I'm going to tip n times here, right? The 1,600 is dividing the A, so it has to multiply to go away. So I'm going to multiply both sides by that. Ne? Awesome. So now here we're going to have this canceling that. And then A will be equals to, let's get a calculator and see. Okay. So on the calculator, we're going to say 3 over 4 multiplied by 1 over 8 multiplied by 1,600. And we indeed getting this value, right? A equals to 150. Then that should give you your 3 marks. Okay. Awesome. So now we know that this is 150 here, right? Awesome. So now let's check this question. They say, use the value of A to determine the values of B, C, and D. So they want us to find that, and that. Ne? So obviously, when I add A and C, I'm getting 200. So obviously, C must be 50, right? So that when I add this and that, I must get that one, right? Perfect. And then when I add C and D, I'm getting 400, right? So obviously here it must be 350 then, right? Perfect. And then to do B is 2 ways. You can add A and B to get 1.2 or B and D to get 1.4, right? So I'll just do it this way. 350 minus 1.4 gives me 1050, right? And then that's it. Then now let's do the last one. Calculate the probability of choosing a female. So female. And has failed. So a female that failed is, so female and failed, they meet in this one here. Do you see it? So it's 50. So you're going to have P female and failed is going to be 50 out of 1,600. Remember, I said always over the one in the corner here, right? Then this should give you how much? 1 over 32 when you press it on a calculator, right? And that's it for this contingency table question. Now we're going to jump into the fundamental counting principles and permutations. If you are in grade 11, you are not supposed to do it. It's a grade 12 content. But if you want to do it for the sake of curiosity, I advise you to go ahead. Okay, awesome. Okay, so here we have 9 cars of different makes, of which 4 are black, okay? So 4 of our cars are black, okay? Are to be parked in a straight line, right? In how many different ways can all these cars be parked? So how many cars are there in total? There's 9 cars. And there is no condition here, right? If there is no condition, we're just going to have a factorial of 9, right? Perfect. Because let me just show you so that it makes more sense. Ne? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So on the first spot, you have 9 cars to pick from, right? And then you are left with 8. Then you're going to be left with 7, 6, 5, 4, 3, 2, 1. Then this is 9 factorial. You see, you multiply everything together. That is 9 factorial, which simplifies to 362880. Right, we can also just verify on the calculator. So you press 9, then shift the factorial symbols there, which is 362880. Do we see it? Perfect. So now we're going to do the next question. Okay, let me just create spaces again. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here there's a condition. They say the 4 black cars must be packed next to each other. So the 4 cars must be always be packed next to each other. So 1, 2, 3, 4. So the 4 cars will be there, right? Now I want to explain something. Let me use a different color. Let's use this one, right? So ladies and gentlemen, remember this is a group, right? This one here, it's a group, right? It's going to be moving as one item, this group basically, because they have to be packed next to each other. Né? But inside here, we can always shuffle them. So inside there, because we have 1, 2, 3, 4, is going to be 4 factorial, right? Perfect. And then now a group acts as one item né, of the entire items. So a group is one item of the entire item. So when I count, it's going to be 1, then 2 there, then 3, 4, 5, then 6. So don't forget, a group, you just treat it as one item of the entire items. But within the group, you do the factorial of the number of items that are inside the group. So in this case, I see is 1 times 2 times 3 times 4 times 5 times 6, which is factorial 6. Outside is factorial 6, and then inside I have factorial 4. So here I'm going to have factorial 4 multiplied by factorial 6. Let's quickly check how much that is. Okay, so I have factorial 4 multiplied by 6 factorial. That gives me 17280, right? So the answer is 17280. And that's it about this question. If you really found this helpful, just like always, don't forget to share with family and friends and to hit the subscription button if you haven't done so. Aluta continua. Tango.